For number 14, do you guys see what they've started to do? What is this right here? This is one of the steps in what? Grouping. Everyone, yeah? Look what's inside the parentheses is the same, right? This is grouping. Take it the next step now. What should I be writing now that what's inside the parentheses are the same? Help me out. What should go inside our both sets of parentheses here? What's the next step of grouping? X to the 6, y to the 4th, minus 9 and 1, parenthesis. What about in the other one? X to the 4th minus 16. Good. I'm just continuing to group. Now that's not a choice because you can keep going. Where can I keep going up here? I do have difference of two perfect squares. Where are they? X to the 4th minus 16. Here you go. What do you want to factor that into? X squared, and 4 and 4. And what do you know about the signs? Plus and minus. Nice job. Now, you don't think it, but ready? Take a look. That is also difference of two perfect squares. Everyone's okay with the 9. You're probably not believing me here. If the exponent is even, it's a perfect square. All right? If the exponent or exponents in this case are even, it's a perfect square. So I can also factor this one into, ready? X to the, divide by 2. 3rd, y to the 2nd plus, take care of the 9. 3, I'm going to run out of room. I apologize. And then down here, x to the 3rd, y squared minus 3. Now, I'm not a big fan that this is a choice, but it is. All right, this is a choice. If you keep looking through, I do have x squared plus 4, x squared minus 4, and all these here. It is choice 4. Me personally, we could keep going. Which one could I keep going on out of the 4 that I wrote up here? X squared minus 4, I could go one more step. And I think they tried to convince you to do that here, but nope, because can I factor x squared plus 4? No. All right, would I like to see an x plus 2, x minus 2, and then have that choice? I do, but this is a choice, so I'm going to keep it. It's the same. I can't go any further. You can rewrite it out if you want, x squared plus x plus 2, x minus 2, but that choice isn't up there. All right, that choice is not going to be up there. Anything else from you guys you want to talk about? All right, how's your power of i's for 15? A, B, and C all have I in it. Can you guys help me do A minus BC? What's A? What do you got in for A? Negative 3 plus 5i minus, now we're going to have to multiply what? 4, was that a minus or a plus? Minus 2i times 1. Okay, can you multiply for me first? We'll do the negative, that minus sign here in a second. All right, dig deep. Make last year proud. Here we go. Ready? 4 times 1. 4. 4 times 6i. 24i. All I'm doing is double distributing. How about negative 2 times 1? Negative 2i times 1. Minus 2i. And then, what do you got here? Minus 12i squared. What? I squared is negative 1, so help me clean this inside the brackets up here. Help me clean this beast up. Okay, again, we just heard it. What's I squared again? Negative 1. So that will give me what here? This whole thing will turn into what? This whole thing right here. Negative 12 times a negative 1. Positive 12 plus that 4 that's hanging out there. 16, yep. All right, stop. Everyone all right where I got 16 from? Yeah. Negative 1, I squared times negative 12, positive 12 plus 4, 16. All right, what about these two little beasts in the middle? Plus 22i. I'm glad if you got to there, because now you have to worry about what here? Minus what? Why did I leave it like this? You got to distribute it through. So it's going to be -3 plus 5i minus 16, which I'm assuming most of you would get. But here, minus 22i. It's tough. It's tough. Watch out for the minus sides. Okay, you guys clean it up and finish it. And we end up with -19 minus 17i. Okay. And like, this is brutal. This test, you know this already. This test is brutal. Here's why. You forget the you forget the negative sign, and you leave it plus 22i, and you combine it with 5i. What are you going to get? That answer. It's brutal. Okay? The smallest mistake they're going to catch you on. All right? It's brutal. Questions? And also, I don't go into this territory at all, but I'm kind of interested, and you can do it on your own to see if you stored in A, B, and C. I don't know. Some of your calculators do the imaginary numbers for you. I don't know. I don't get into that territory because I know some don't. So I don't know. That's something to check out on your own. If you did stored in A, B, and C, and did A minus B, C, see if you get the same thing. All right, because if you do, you're on good track. Any questions, guys, for me? All right, we got a quiz coming up tomorrow. It's on the first 3 days of stats, controlled experiments, observational studies, population versus a sample, mean, median, mode, all those values under 1var stats, and including what we do today. All right, I have a quick question for you from Friday. I'm going to pretend I wasn't here, so maybe you can help me out. Let me get up a quick 1var stats up here. Okay, boom, boom. How many standard deviations are listed up here? How many standard deviations are listed here? 2? Guy's unbelievable. There are 2. Yes, there are 2. What is this one called? That's sample standard deviation. And the other one here is population standard deviation. If one is not specifically asked for, which one do we use? Population. There we go. Okay. We all good? Tomorrow will be specifically asked. If it's not, use the population. All good. Can we do a review question real quick? In your notes, if you go to page 13, number 7, we're going to do a quick review one, making sure if this comes up on tomorrow's quiz, we'll be ready. So last question in today's notes, number 7. Okay, we got 20 scores of the exam. Don't start putting them in your calculator yet. We got to talk about what I need to do here. So here are the 20 scores. Determine the percent of students that scored within one of the mean, with one standard deviation of the mean. We did this on Friday. So I have the mean in the middle. Within one, right? Within one. So how do I go this direction? Add what? Add what? The standard deviation. Yep. And then how do I go this way within one here? Subtract the standard deviation. Guys, where do I get these values so I can do that? List 1var stats. Go ahead. List 1var stats. Put in those 20 scores. Go ahead and you can round to the nearest 10th when you get those values. Round to the nearest 10th. Take your time entering them in your calculator, because I warned you guys on Friday, and 88 may just be 8. Do a quick glance when you're done typing them in. Do I have them all correct? As you're typing, guys, how many lists are you using? Just one. So when you go to one var stats, just make sure L1 is in there. Get L2 out of there. You're only using one list. Just so you know we're on the right track, what'd you guys get for the mean? 79.7. Yep, nice job. If you guys aren't getting 79.7, it's got to be you typed in a number wrong. Got to be. What's your standard deviation? About 8.7. Yep. So everyone go ahead. Add in 8.7 right now. Add in 8.7. What's on the upper end? 88.4. And then what's on the lower end are within one standard deviation. It's about 71. All right, 71. Okay, so this is within one. Any score that's from 71 to 88.4 is within one standard deviation. Find how many there are, because you need to tell me what percent is in between there. Take your time, cross them off, circle them, happy face them, I don't care. Okay, because you got to find the percent. How many are within one? Anybody confident they counted up the correct number? What do you got, Jason? 14, all right. I wasn't asking for how many scores, though. I was asking for the percent. So not just to you, I'm just talking to anybody. 14 out of how many scores? 20. That's what percent? 70% are within one. Yep. Questions, comments, any concerns? We okay there? Within one. Add and subtract. What if I said more than one above the mean? What scores would you be looking for then if I said more than one above the mean? Anything above 88.4. Yep, anything above 88.4. Tomorrow, I cannot help you how to use your calculator. Okay, so if you're not using your own, you're a borrower, I don't care, but I cannot help you use the calculator tomorrow. All right, so please be aware of that. Okay, I cannot help you use the calculator tomorrow. All right, moving on, because we're going to more calculator stuff, so go ahead and go back to the beginning of today's notes. All right. So we've been finding standard deviations and means a very small amount. So we just did 20 test scores, not a big amount. What about when you take the SATs? That's a lot of people taking it, correct? Okay, so how do they calculate, one, the mean? How do they calculate standard deviation? And most importantly, we're going to find out today is, where do you rank? Do you rank in the top 10? rank in the percent, which isn't good because that means only 27% scored below you. All right, how do they find this out? They find this out by using this curve I'm going to introduce to you now, which is called the normal curve. Okay, this is when you have a lot of scores. Okay, and where do you fall in? We use what's called this normal curve. Let me explain it to you first before we use it. Everyone see, it looks symmetrical, doesn't it? If you draw this line, vertical line right down here, these percents match these. And if I added up all the percents, any idea what they all add up to? 100%. So guess how much percent's over to the right and to the left here? 50 and 50, yep. And it's always split right at this 0 mark. The 0, that's your mean. All right, whatever the mean score is, that goes at 0. Okay? And all these numbers here, 0.5, 1, 1.5, and going to the left, negative 0.5, negative 1, those are the standard deviations. Okay? Standard deviation. So if you guys go ahead, draw a line from negative 1 to 1 right there. We've been talking about that concept. That is known as within one standard deviation. Okay? Within one standard deviation from negative 1 to 1. If I drew a line from negative 2 to 2, that would be within 2 standard deviations. All right? All right, I just want to jump in and get after it. You ready for this? Number 1. I love this one. Love this. Hope you guys like it just as much. Probably not, though. I'm just going to keep my hopes up. Okay. Set of measures that follows a bell curve. Stop right there, everybody. This normal curve is also known as a bell curve. So this right here telling me it represents a bell curve tells me, hey, use these percents in the chart right now. Use these percents. A mean of 80. Where's the 80 go? At 0. So everyone, where you see the 0, just right below it, write the number 80. That's my mean. It also tells us the standard deviation is 5, which means the following. When I add 5 to the mean, I get the score at 1. So everyone add 5 to the mean, what do you end up with? 85. So the score at 1 above is 85. How do you think you find the score at 1 below? Subtract 5. Beautiful. So what's the score at negative 1? All right. Let's go back to the problem. What percent of students fall between 75 and 85? Oh, 80, sorry. 75 and 80. Everyone see where we put 75 and 80? So what we're just going to do is, the chart gives us the percents. So I'm going to add up, that's garbage because you can't see it. I'm going to add up the percents from 75 to 80. And because it follows a bell curve, that's the percent of students that scored between a 75 and an 80. Yep, I got you. That's 19.1. And that's a 15.0. I know it's tough to see. I needed to fit it in the problem, sorry. So it's telling us, hey, add 15 plus 19.1. What percent of students scored between a 75 and an 80 for us? 34.1% of the students who took this, whatever it represents, 34.1 scored in between a 75 and an 80. All good. Anything here? I know first one's not the best. We'll get a little comfortable with the next one. All right. A set of scores. A set of scores with everyone take a look. Normal distribution. That's the key word we're looking for here. Words. Normal distribution means I can use this normal curve. A mean of 50. Where are you putting the 50? At 0 again. Standard deviation of 7. What's the score at 1 above? 57. I add it. And then how do you find the score below? Subtract it. So that's going to be, oh boy, 43. Thank you. But if I read the problem, I didn't do enough work. Because what am I trying to find? The percent between? Okay, I didn't do enough work. I got to keep going. All right. What do I keep doing to get to 2 above now? Add another 7 onto 57. So I'm at Ooh, yeah, I like that. 64. How do I get to 2 below? Keep subtracting 7. 43 minus 7. Ooh, I like that. 36. So do we have our range? What percent scored from 36 to 64? You're darn right we do. So I'm going to add up all those percents in between, within. Anybody need help reading any of them? Good talk. I'll just let you find the percent. In between 30, because it says the range of 36 to 64, so I need to add up all those percents. And what are we getting? 95.4%. Yes. I would like you to be familiar with that number, 95.4 or 95. Here's why. We're going to be doing a couple problems later on that involve that percent. Anybody tell me 95.4% of the scores fall? How do I describe this from -2 to 2? Fall within 2 standard deviations. So make a little note here because you're going to see this 95% again. Within 2 standard deviations is equal to 95, about 95%. Okay, within 2 standard deviations. Can you guys also, while we're here right now, find me what percent of scores fall within 1 standard deviation right now? Because that's another number you're going to see quite a bit. Can you guys now add up all the percents that fall within 1 standard deviation? Because this is another number we're going to see quite a bit. What do you got within 1? 68.2. I'm just going to say 68. All right. You may see 68.2, but 68. So 95 and 68 are percents we want to be aware of within 2 and within 1. Whew! Questions? Because we got a problem. We got a problem. We have a problem. All right, ready for the next one. A test was given. Yep, scores. Ooh, normal distribution. There it is. Means I can use the curve, right? And the percents underneath. Mean is 72, standard deviation is 7. What percent? Oh, this is not a big deal. We've done last 2 problems like this. Everybody stop. Do you notice I did not give you one of those curves to work on there? And I don't expect you to go back and reuse one of the other ones. Here's the problem we're in for right now. Everyone ready for the problem? We're all familiar with this, correct? The reference sheet. This is the same one we're going to get in 6 weeks from Thursday. We can use anything on there. What's not on here? The curve. The curve's not on here. And do you think, I know the answer, you don't have to say it out loud, but do you think I'm going to have you memorize those percents underneath the curve? I wouldn't do that to you. I know I'm harsh most of the times, but I wouldn't do that to you. How are we going to get them then? Just out of thin air? No. Everyone's calculator has the curve built into it. Shocker. All right. I just got to show you today how to access it. All right. These percents that are underneath the curve are already in your calculator. You just got to pull it out. So here's where we go now to get those percents. On your calculator, blow that sucker up. You have above the VARS button, D-I-S-T-R, short for distribution, which is what we're doing. So second, VARS. Guys, there is only one we're going to attack this unit, and that is number 2, normal CDF. Normal CDF. All right, that's the only one we're going to use on this screen is normal CDF. Now, you will see Now, some of you don't have this because your calculator may not be updated or you're just using an older version. I'll be with you in a second, all right? How many of you have this screen right now so I can at least deal with that? Perfect, majority. If you don't, just settle down for a second. And it won't let me go down. I'm just trying to delete these values because this is for another problem. And it's not going to let me. Okay, so here you go. Let me just describe here. This is the lower part of the range I'm asked for. The upper part of the range. This is a new symbol here. It's also called X bar. What's that for then? That's the mean I put in there. We are familiar with that beast. What's that one? That's my my standard deviation, right? So lower end of the range, upper end of the range I'm looking for, mean, standard deviation. We all good? Go back to the problem we're solving. We're looking for what? Approximately what percent of the scores are? 65 or higher, correct? So what's my lower end of my range here? Everyone agree it's 65. So that's what's going to go in first there in my calculator, 65. Because it's 65 and above. Now, let's talk about the upper. They don't give me an ending, do they? And I do not assume it's 100 because it's a 100-point test. You never know. They do not give me an end value. So what we need to do when there is no end value, we need to put the highest number the calculator can handle. And here's how we put it in. It is 1. Ready, everybody? 1. 1. And everyone see you got double E's above the comma. 1 E 99. Here's what you just put in your calculator for the upper end. 1 times 10 to the 99th. It's the highest number your calculator can handle. Okay, that is anytime we're not given an upper bound, all right, for the range, we're putting in 1E99. Guys, help me out. What's the mean that tells you in this problem? 72. And what's the standard deviation? 7. There it is. Now let me paste. Now you guys that don't have this screen, do you have this screen that says normal CDF with saying something, plug me in, plug something in here? Do we have at least that screen? Because if you have this one, now you got to type in on your own 65, comma, 1E99, comma, 72, comma, 7. Okay, so you guys that didn't have that screen I had up before, you got to make sure you remember lower, upper, mean, standard deviation goes in. And we hit enter. Okay, what's that number represent? That's your percent, but as a decimal. So if you want to see it as a percent, what do you suggest I do to that? Multiply it by 100. Yep, that's your percent as a decimal right there. So what percent scored above a 65? About 80%. Your calculator do it. And we got that same thing and added percent. So we would have got about 84%. Okay. There. That's nice. Calculator does it for you. It'll be on the quiz tomorrow too. All right, Arlington High School SAT exams. Read through. Everyone see that eventually they are normally distributed. Yep. So that tells me normal CDF. Oh, Big Sue scored a 740. Well, watch what the answer comes out to be. What percent scored below her? Below her. So what are we looking for? 74 and below, right? 740 and below. 740 and below. Okay, ready? So second VARs, normal CDF. All right, now there's no lower bound now, is there? And you just can't, oh, it's an SAT, so I'll just put in 0. No. We got to go as low as we can go. So what do you think? If high as we can go is 1e to the 99th, negative 1e to the 99th is as low as we can go. And what's our upper bound? How high are we going? What was her score? 740. The mean? 540. And the deviation. 80, right? All right. Okay, so as low as we can go, negative 1e to the 99. As high as we can go, 1e to the 99. Paste that sucker in. And you'll actually find out she did pretty darn good. Because what percent of the score scored below her? Yeah, 99% scored below her. 99.3 I'll put. Before I go on to the next one, because you will see these problems on the Regents exam and on our quiz and test, how do you show work? Because you just can't write down 99.3 and that's it. How do you show work? And it's the greatest thing ever. Ready? All you need to show me is that right there. Normal CDF, and show me what you're plugging in. So normal CDF, and then show me the correct order, what you're plugging in. So negative 1e 99, 740, 540, comma 80. That's all you need for work. It's beautiful. What's that? On the Regents as well. Yes. Yep. That's what we're expecting. Hi, Grace.
Hey.
Hi.
Or not the quiz.
Yes, there is a quiz tomorrow.
Is this on the quiz?
Yes, it is. Yes.
Okay.
Yes, it is. This is on the quiz along the last 2 days.
No, I'm just not.
All right. We're good. No issues. How are we feeling? All right. All right. Cans of soda. Again, it's normally distributed. Boom. So I know I can go to normal CDF. Okay, I got the mean. I got 0.6. 250 cans were pulled. How many can be expected to have? Here you go. Here's our range. Less than 11.1. Less than 11.1. So what's my lower here? Think about it. Less than 11.1. What's my lower here? Negative 1e. Everyone see why? Because it's 11.1 or below. Less than 11.1. What's your upper bound here? 11.1, followed by the mean, 12, and standard deviation, 0.6. I got a little snag on this one for you, though. He always does that. I know what's going on, and he pulls that business. What's the mean again? 12, and then 0.6. Okay, you got to read the question. I'm asking for the person in this one. I want to know how many cans. So you had 250, out of those 250, how many are 11.1? Well, it already tells you the decimal, right? You can, if you want, turn it into a percent, if that helps. So about 6.68% of the cans. But what do I do with that 250 to find out how many cans? The percent. I want to know how many cans. Multiply the 250 by the percent as a decimal. So you guys can go right in your calculator right now. Go back up to that number it gave you, because that's as a decimal, and then multiply that by your 250. And there's about how many cans? About 17 cans, yeah. So 250 times, what was it, 0.0668. Okay. Feeling all right? Yeah, we got one more in us, and then you're just going to go nuts on the assignment. Yeah, I was going to pretend I didn't hear that, but I'm not sure what that was. Okay. Flipping it on you now. Flipping it on you. I'll give you the mean is 56, standard deviation's 5. Now, I want the interval. I usually give you the interval and you give me the percent back, but I want the interval now where 95.4% are. Woo, timeout. Don't go to your calcs. Where have we seen that number? I told you it was going to come up, 95.4. That's within 2 standard deviations, correct. So here's what I need from you. If I have 56 as the mean, and I go 2 standard deviations this way, 2 standard deviations to the left, what are those scores? That's what I need your help with. And how do I know it's 2 versus 1? How do I know it's 2 versus 1 standard deviation? 95%. If it was 68, then I'd go 1. All right, help. 56. I need to get over to 2. How do I do it? Add 5 and then add 5 again. So if I add 5, that'll bring me to 61. Add 5 again. 66. How do I go over to 2 in the other direction, to the left? Subtract 5. And that'll bring me to 51. Subtract 5 again, and it'll bring me to 46. So the range is between 46 and 66 for 95% of the scores. All right, if I saw 68, I'd only go within 1. Let's go. Go. Flip it and go. Let's go. Yes, it is much worse after the quiz. I dread it myself.
I should go to Shy.